Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Hazid Sufyan bin Wan Zain. My student ID 2023871404. So today I will presenting my final year project titled Design and Fabrication of Impact Machine using Pneumatic System, which was complete under the supervisor of TS Muhammad Ridwan Muhammad Reza. The objective of this presentation is to explain the background of the project, the design process, system components, experimental results, and the overall performance of the Pneumatic Impact Machine. So, this presentation is divided into 5 chapters: Introduction, Literature Review, Methodology, Results and Discussion, followed by Conclusion and Recommendation. So for this chapter 1 is cover the objective, introduction and the scope of work. Pneumatic is a branch of automation that use compressed air to transmit and control energy. Pneumatic systems are commonly used in applications such as automatic doors, vehicle braking systems, industrial automation and clamping mechanism. The reason pneumatic systems are widely applied is because they are clean, safe, cost-effective, and easy to maintain. Unlike hydraulic systems, pneumatic systems do not use oil, which reduces the risk of leakage and environmental pollution. This project focuses on the design and fabrication of pneumatic impact machine that is capable of delivering repeated impact loads in a controlled manner. The machine is designed to operate under laboratory conditions with an emphasis on safety, reliability, and ease of operation. Automation plays an important role in this project as it helps reduce manual effort while improving consistency. However, due to the use of sensors and compressed air, proper safety precautions are necessary during operation. The objective of this project are as follows. First, to design a mechanical structure that is able to withstand repeated impact load without a structural failure. Second, to fabricate a functional pneumatic impact machine that includes a safe and user-friendly control systems. So the scope of this project begin with a literature review and research on pneumatic systems to understand their working principles, advantages, limitation, and safety requirement. After that, the mechanical structure of the impact machine was designed using sketches and computer-aided design software. The design focused on strength, stability, and ease of fabrication. Next, suitable components were selected, including the pneumatic cylinder, solenoid valve, FRL unit, air compressor, sensor, and control system. Once all components were selected, fabrication and assembly were carried out. The final stage involved testing the system to ensure proper operation, safety, and absence of air leakage. The chapter 2 for the literature review is cover the advantages and disadvantages of pneumatic system and also the sensors. So for the advantages and disadvantages of pneumatic systems, pneumatic systems offer several advantages that make them suitable for impact machine applications. They are environmentally friendly, safe, and relative low cost. Their simple designs allow for easy maintenance and quick installation. In addition, pneumatic systems do not pose fire hazard and are suitable for laboratory environments. However, pneumatic systems also have limitations. The force output is lower, compared to hydraulic systems because air is compressible. Pneumatic systems typically operate at pressure between 6 and 7 bar, while hydraulic systems operate at much higher pressures. Due to their limitations, pneumatic systems are not suitable for applications that require extremely high force. Sensors are essential component in pneumatic systems to ensure accuracy and safety. Magnetic proximity sensors are commonly used to detect piston positions inside a pneumatic cylinder. This sensor provide feedback for extension and retraction movement. Pressure sensors are also used to monitor air pressure levels and prevent the systems from operating beyond safe limits. The integration of sensors improve reliability, repeatability, and operation safely. For the chapter 3 methodology, is cover the introduction, flowchart, and also the expected result. This chapter describes the methodology used to complete the project. The process started with careful planning and system design. Initial sketches were created, followed by detailed modeling using fluid sim. A flowchart was developed to visualize the overall workflow and identify potential errors during fabrication and assembly. A morphological chart was used to evaluate different design alternatives and component options. A per chart was then applied to select the most suitable design configuration. After finalizing the design, the fabrication process was carried out. All components were assembled according to the design layout, ensuring proper alignment and secure mounting. Finally, testing and troubleshooting were conducted to verify the system operates safely and efficiently. This slide shows the flowchart of my project methodology. The flowchart is important because it helps me plan the project systematically and avoid major errors during fabrication and testing. The process starts with problem identification, where I define the objective of designing a pneumatic impact machine capable of delivering repeated impact load safely. Next, I carry out literature review and research to understand pneumatic systems, proceed suitable component safety requirement and previous related work. After that, I proceed with the design stage, where I can create sketches and 3D models using fluid sim. At this stage, the mechanical structure and system layout are finalized. Once the design is complete, the next step is component selection, such as at the pneumatic cylinder, solenoid valve, FRL unit, air compressor, and sensors. The project then moves to fabrication and assembly stage, where all components are assembled according to the design. After assembly, testing and troubleshooting are carried out to check cylinder motion, impact performance, air leakage, and safety features like the emergency stop. If any issues are detected, adjustments are made before proceeding further. Finally, once the system operates safely and performs as expected, the project is completely ready for evaluation. The expected outcome of this project is a fully functional pneumatic impact machine capable of delivering repeated and consistent impact loads. The machine is expected to operate with minimal vibration and noise while maintaining safety and ease of use. The system is also expected to be cost-effective and suitable for laboratory applications. For the chapter 4 result and discussion, discover the result and also the component use. This slide shows the main component used in my pneumatic impact machines. Each component plays an important role to ensure the system operates safely and efficiently. The first main component is the air compressor. The air compressor supplies compressed air to entire pneumatic system. It provides the required air pressure that is used to drive the pneumatic cylinder. Next is the FRL unit, which stands for filter, regulator and lubricator. The filter removes dust and moisture from the compressed air. The regulator controls and maintains the desired air pressure. The lubricator ensures smooth operation of pneumatic components by reducing friction. The solenoid valve is used to control the direction of airflow to the pneumatic cylinder. When the solenoid valve is activated, it allows compressed air to flow and causes the cylinder to extend or retract. The pneumatic cylinder, specifically a double-acting cylinder, is the main actuator of the system. It converts compressed air energy into linear motion, which produces the impact force required for the machine operation. The punch is attached to the end of the piston rod. Its function is to transfer the kinetic energy from the moving piston to the test surface, creating the impact. The sensors such as proximity sensors are used to detect the position of the piston. The sensor help ensure accurate movement, control and improve safety during operation. The control system manages the operation of the solenoid valve and sensors. It allows the machine to operate automatically and ensure safe and repeatable motion. Lastly, the mechanical frame supports all components and absorbs the repeated impact loads. The frame is designed to be strong and stable to maintain safety and machine durability. As you can see, the result, the photos of my project. Experiment testing was performed by operating the machine at different pressure levels. The result shows that increasing air pressure increase both impact force and cylinder motion. However, operating at excessively high pressure leads to increased vibration and noise. Based on the experimental results, an operating pressure of 5 bar was identified as the optimal pressure. At this pressure, the machine delivers consistent impact force with stable operation and acceptable noise levels. This result confirmed that the pneumatic impact machine meet the design objective and operates reliably under laboratory conditions. So the chapter 5 is cover the conclusion and the recommendation. In conclusion, this project successfully achieved all its objectives. A pneumatic impact machine was designed and fabricated to deliver repeated impact load while maintaining structural stability and reliable performance. The use of a double-acting pneumatic cylinder provided consistent motion, and the system was proven to be safe and user-friendly. Overall, the project demonstrates that pneumatic systems are an effective solution for controlled impact application. Several improvements can be considered for future development. First, additional sensors can be installed to improve data accuracy and monitoring. Second, the use of higher quality fitting and hoses can reduce air leakage and pressure loss. Lastly, implementing automated or electronic control systems can enhance precision, consistency, and efficiency. That's all from me. So I hope you guys enjoy my video, and if they have any question, you can ask me later. So thank you, and Assalamualaikum warahmatullahi wabarakatuh.